எதுல இருக்கும் மேம் பேரபோலா?
Meenakshi ma'am. Hello Meenakshi ma'am. Okay. A very good morning and a hearty welcome to everyone in today's national level online webinar on real life applications of mathematics, organized by the Department of Mathematics of M.D.S.D College, Ambala City. I extend my warm welcome to our resource person, Dr. K. Meenakshi, Professor, Department of Mathematics, CMR Institute of Technology, Bangalore. I, on behalf of whole M.D.S.D College, would like to express my thanks to Dr. Meenakshi for sparing her time to share her knowledge with all of us. I welcome our worthy principal ma'am, Dr. Kiran Angra, who has always been a source of inspiration and motivation for all of us. A dream doesn't become reality through magic. It takes sweat, determination, and hard work. Yes, it's a belief endorsed by our principal ma'am. I welcome you, ma'am, and I acknowledge your presence. Today, we all have gathered on this virtual platform to listen from Meenakshi ma'am on the topic real-life applications of mathematics. The prime objective of the webinar is to enable the participants think analytically about the world and reason logically. Dear all, Dr. Meenakshi has 23 years of teaching experience and has presented and published a number of research papers in national and international journals. She is also guiding 3 students under VTU and has filed 2 patents under her name. I welcome you, ma'am, and now I invite you for your session. Over to you, ma'am. Meenakshi, ma'am. Participant, there was some technical issue. Meenakshi ma'am is joining us within a few seconds or minutes. Hello, Meenakshi ma'am. Am I audible to you?
Hello. Good morning.
Yes,
Am I audible?
yes, ma'am. You are audible. Yeah, I welcome you, ma'am. Now I invite you for a session.
Yeah. Sorry for the trouble.
No, no. Yeah, this is a technology, so you have to face some glitches in it as well.
Please, you want to share the screen, please enable screen share.
Ma'am, I am making you the co-host. Then you will be able to share your screen.
Okay.
Yes, ma'am. I have made you the co-host. Yes, ma'am. Your screen is visible.
Hello.
Yes, ma'am. You
Good
are
morning,
audible
everyone.
and your okay.
Good morning, everyone. Today I will talk about real-time application of mathematics. I will touch the basics of mathematics and I will discuss about few of its applications. All of us know what is mathematics. We are learning maths since our childhood. So mathematics is basically the study of abstract things. The first thing which was started in mathematics is counting. So we need something to represent group of objects. For that, people started using 1, 2, 3, etc. So which are numbers, which are abstract. Then came the study of shapes. We have different shapes. We call different shapes by different names, and then we have different patterns. So basically, mathematics is a study of abstract things like numbers, shapes, and patterns. It is a king of arts and queen of all sciences. All of us are aware of the saying that mathematics is a king of arts and queen of all sciences. It is a living science where problems and theory come from the discipline itself.
Sorry to interrupt you, ma'am. Actually, your voice is shaking. We are not able to hear you
Okay,
properly.
okay, ma'am. Yeah,
Yeah.
mathematics is the study of abstract things. Can you hear me? Hello.
Yes, ma'am. Still, it is not that much audible.
Mathematics is it okay, madam?
No, ma'am. There is some problem, I think.
Um, Few minutes. One. Hello.
Yes, ma'am. Hello.
Yeah. Hello. I'll start again.
Okay. Okay. Fine.
Okay. Is it okay?
Yeah, ma'am. It seems to be.
Yeah. So the mathematics is the study of abstract things like numbers, shapes, and patterns. So the subject has started with counting. We all we need something to represent group of objects. So for that, people started using numbers like 1, 2, 3, etc. So which are abstract. And then we have there are different shapes. People call different shapes by different names, and then followed by patterns. So we can say that it is a study of abstract things like.
Ma'am.
Hello.
Yes, ma'am. Still, there is some problem with your voice, I think.
Yeah. Is it okay, madam? Hello.
Ma'am, it seems to be, but when you start presenting it, there is some disturbance when you speak.
Okay. I
So,
start. It is a study of abstract things like numbers, shapes, and patterns. Is it fine now? Hello.
yes, ma'am, it's not that clear. There is some
I'll
your
switch,
voice is shaking.
okay, I'll switch off the fan. Yeah.
Okay.
Hello. Hello.
Hello, yes, ma'am.
Is it fine now?
Yes, ma'am.
Yeah. So basically, mathematics is a study of abstract things like numbers, shapes, and patterns. The subject started with counting. So people needed something to represent group of objects. So they started using numbers 1, 2, 3, etc., which are abstract. And we have different names for different shapes, which are also abstract. So basically, it is a study of abstract things like numbers, shapes, and patterns. And mathematics is a living science where problems and theory come from the discipline itself. There is, we all are aware of the saying that it is a king of arts and queen of sciences. There are two branches of mathematics, pure mathematics and applied mathematics. Few mathematicians study mathematics for their own sake, for its own sake, and they derive something in mathematics. Applied mathematics is application of mathematics to other fields. So it is more than a tool and methodology. Applied mathematics is application of mathematics to other fields. So that's why it is more than just a tool and methodology. So the meaning of mathematics is the science of numbers and their operations, interrelations, combinations, generalizations, and abstractions. So there are many branches of mathematics. So basically, the oldest branches of mathematics are arithmetic, geometry, and algebra. Now, what is arithmetic? Arithmetic is a branch of mathematics that deals with properties and manipulation of numbers. So, numbers, counting numbers starts with one. We have the number system that is natural numbers or counting numbers, which starts with one and one, two, three, etc., which was used to represent group of objects. Then zero was added to the system. So we have the concept of whole numbers. So whole number starts with zero. So we have 0, 1, 2, 3, etc. And we need numbers to represent forward direction and backward direction. Say, for example, I can walk 2 steps forward and I can even walk 2 steps backward. So for that reason, we have the concept of integers. So we have numbers to represent the reverse motion, that is opposite direction. So for that we have integers, and then we have fractions, that is rational numbers. What happens when one cake is divided among 4 people? How much each person will get? So that is fractions. So that is a rational number. So rational numbers contains natural numbers, whole numbers, integers. And apart from rational numbers, we have numbers which cannot be expressed as P by Q. The numbers which cannot be expressed in rational form, P by Q, where Q is non-zero, they are called as irrational numbers. So say for example, root 2 is an irrational number. We cannot express root 2 as P by Q form. So the union of rationals and irrationals.
Sorry to interrupt you, ma'am. Your voice is breaking and
Hello.
hello, yes, ma'am, your voice is breaking in between.
Okay. Um, the union of
I
rational.
think
The
no,
union of.
ma'am, your
Okay.
voice is breaking. We are unable to listen you properly.
So what should be done further? I
Ma'am,
have increased the
I
volume.
will request you to join.
Join.
Yeah, I think there is some network problem. That is why we are unable to hear you properly.
Okay. So what can be done?
Like you can join from your another device. So like you can share your PPT from this one and you can speak from there.
Okay, I will try that.
Okay.
Hello. Can you hear me?
Yes, ma'am, we can hear you, but there is an echo. Like I think due to the another device, you have to like put the other device on the mute option.
Hello.
Hello, hello, Meenakshi ma'am. Hmm.
Hello, can you hear now?
Yes, ma'am, I can hear you. Ma'am, you can like proceed with the presentation. Hello, Meenakshi ma'am.
Hello. Yeah, I will join in 5 minutes. Yes.
Yes, ma'am, your screen is visible. Uh, Now I invite you again for like proceeding with your presentation.
Hello.
Yes, ma'am,
Hello.
you are audible. Yes, Meenakshi, ma'am, you are audible.
Hello.
Yes, ma'am, you are audible.
Hello.
Ma'am, you are audible.
Hello.
Yes, ma'am, you are audible. You can proceed with your presentation.
Okay. Yeah. So, arithmetic is the oldest branch of mathematics, which deals with properties and manipulation of numbers. It is a Greek word. Arithmetic means number, and elementary aspects of theory of numbers. So, we have a real number system. The real number is a union of rationals and irrationals. And so, what are the rational numbers contains natural numbers, whole numbers, integers, and fractions of the form p by q, where q is non-zero. And there are numbers which cannot be expressed as p by q, which we call it as irrational. So the union of rationals and irrational forms the real number system. Um, and apart from real number system, we have the complex numbers. So complex numbers are there only to find the square root of negative numbers. The real numbers is a superset of all numbers, and complex numbers contains real numbers. So in arithmetic, we deal with real and complex numbers, and there are larger numbers which we use in day-to-day life. That is the numbers for representing the cells in human body, the number of cells in the human body, the number of bits on a computer hard disk, and number of neuronal connections in the human brain. These are all examples of large numbers. So large numbers are technically described as numbers bigger than what we use in daily life. So like examples like 1 lakh, 1 million, 1 billion, and so on. So the numbers which are ordinarily bigger or greater than the other numbers are called as larger numbers. So what is arithmetic? It is a branch of mathematics which deals with properties and manipulation of numbers. So what are the basic operations? We all know the basic operations are addition, subtraction, multiplication, followed by division. So we know that repeated addition is multiplication, and we have arithmetic progression. So you can find in the figure there is one box, three boxes, five boxes, and so on. So you have the sequence of 1, 3, 5, etc. So this is an arithmetic progression. Then we have arithmetic sequence. So where we can find arithmetic sequence, we can find in kitchen stacking cups, and we can find the arithmetic sequence in the seats, in the auditorium or stadium. So the examples for arithmetic sequences are stacking cups, chairs, bowls, pyramids, and the seats in stadium or auditorium. So these are real life examples of arithmetic sequences. So similar to arithmetic progression, arithmetic sequence, we have geometric progression, geometric sequence, harmonic progression, harmonic sequence. Next, the next oldest branch of mathematics is algebra. So what for we have algebra? In arithmetic, we deal with fixed numbers. But in algebra is mainly used to find the unknowns. See, there are problems where we don't know what is it. So we call it as some variable. So say, for example, the height of a child. The height of a child varies with age. The temperature at different places are different. The speed of a car varies with time. So algebra is a study of variables and operations among variables. The word algebra comes from the Arabic word al-jabr, which translates to reunion of broken parts. So Muhammad Musa al-Khwarizmi is a Persian mathematician, is regarded as father of algebra. So algebra is a study of variables which we use to represent the unknowns and the rules for manipulating the variables in formulas. So it is a unifying thread of almost all of mathematics. So like arithmetic, algebra is also the oldest branch of mathematics. We have applications of algebra in real life. We can find application of algebra in cooking, sports, shopping, computer programming, business, health and fitness, and interiors. So if you take cooking, we have to use the right proportion of ingredients to get a tasty dish. So we have to use the right proportion of ingredients to prepare a tasty dish. So the ingredients are nothing but the variables. And algebra is used in interior planning, landscape design, and also in architecture program. The designers use data such as measurements of space and size of items to locate the correct elevation or to determine the collection of items to be used in space. And algebra has also applications in computer programming. The programmer make use of data sets, strings, and variables. The conditions are assigned to the strings and relationships are established, which result in the action in the front end. The conditions are the variables, and the front end result is the outcome. So this activity of coding, assigning values, and predefining the functions is actually where we apply the knowledge of algebra. It helps us to create the codes that work amazingly and also to meet our coding objectives. So computer programming is mostly done in terms of data sets and variables where algebraic operations are performed. And the next example is business. We use algebraic operations for calculating profits and losses. Then the next oldest branch of mathematics is geometry. So geometry is a branch of mathematics which deals with shapes, angles, dimensions, and sizes of variety of things. It is an ancient Greek word. Geo means earth, metron means measurement. So the common types of geometry are plane geometry, which deals with objects like line, circle, triangle, polygon; solid geometry, which deals with objects like line, sphere, polyhedron; spherical geometry, which deals with objects like spherical triangle and spherical polygon. Euclid was a great mathematician who is called as a father of geometry. Geometry is concerned with the properties of um, distance, shape, size, and relative positions of figures. A mathematician who works in the field of geometry is called as the geometer. And here we have some examples of 2D geometry: line, circle, triangle, square, so on. Coordinates, we have coordinate geometry. So coordinate geometry in two-dimensional space, each point is identified as a pair of numbers, which it is written as XY. So coordinate geometry is a branch of geometry that the position of the points in the plane is defined with the help of ordered pair of numbers. So every point in space is identified with an ordered pair XY, and we call X as the abscissa and Y as the ordinate. So the 2D plane is divided into 4 quadrants. We have first quadrant, second quadrant, third quadrant, and fourth quadrant. So first quadrant, both X and Y are positive. Second quadrant, X is negative, Y is positive. Third quadrant, both X and Y are negative. Fourth quadrant, X is positive and Y is negative. Now, coordinate geometry is a study of geometric figures by plotting them in the coordinate axis. Figures such as straight line, curves, circles, ellipse, hyperbola, polygons can be easily drawn and presented to scale in the coordinate axis. So we have learned different formulas with coordinate geometry. The distance formula, distance between 2 points in a plane; the midpoint formula, the point slope form, the slope intercept form, and the general equation of a straight line. Next comes trigonometry. The trigonometry is a branch of mathematics which is concerned with relationship between angles and ratios of lengths. So it deals with relationship between the ratios of sides of right angle triangle with its angles. So the trigonometry is a branch of mathematics which deals with the relationship between the ratios of sides of right angle triangle with its angles. So we know the famous theorem, Pythagoras theorem of right angle triangle. The ratios are used to study the relationships which are called as trigonometric ratios. So we have sine ratio, we have the ratios like sine, cosine, tangent, cotangent, secant, and cosecant. The word trigonometry is a Latin derivative, it's a 16th century Latin word, and the concept was given by Greek mathematician Hipparchus. So we know this is a right angle triangle. We know to find sine, cos, tan, area of a triangle, and we have the Pythagoras theorem also here. The a square plus b. So here we have some applications of trigonometry. Say, let's say the height of a palm tree. So she tries to the person tries to locate the topmost point of the tree. So they imagine a line from the topmost point to her eye. That line is called as line of sight. So the line from her eye to the topmost point of the tree is called as a line of sight. And she also imagines a line her is parallel to the earth, which is called as horizontal line. She also imagines a horizontal line parallel to earth. And so the angle between the line of sight and the horizontal line is called as angle of elevation. The line of sight is above the horizontal line, and the angle between the line of sight and the horizontal line is the angle of elevation. Now, similar to angle of elevation, we have angle of depression. Let's say that we are standing on top of a building and we want to find the distance of borewell from the building. So we observe the base of the borewell, and the line of sight from the eye to the base of the borewell, it is the line from the eyesight to the base of the borewell, it is a line of sight. And we imagine a line parallel to the earth, it is called as horizontal line. The angle between the line of sight and the horizontal line is called as angle of depression. So this angle is called as angle of depression. And we have some more examples of trigonometry. We have seen electric poles. Electric poles are present everywhere. They are usually erected using a metal wire. The pole, the wire, and the ground. The pole, the wire, and the ground form a triangle. If the length of the wire decreases, we still can find the shape of the triangle and the angle of the wire with the ground. And we have another example. Let's say a person is whitewashing a wall with the help of a ladder. And if the person wants to paint at a higher position, we can find the change in the angle of the ladder with the ground. And in a playground, children like to slide on a slider. The slider is on a defined angle from the earth. We can find the position of the slider when we change the angle. So we can also find up to which angle it is safe for children to slide. So basically, trigonometry has applications in making slides to find the distance of sun from the earth, and it is also used to find the length of the wall. And so in a playground, children like to slide on slider. The slider is defined on a defined angle from earth. So trigonometry is used to design the slides. It is also used to set direction from north, southeast, west, and on which direction to take with a compass to get on a straight direction. It is used in navigation in order to pinpoint the location. It is also used to find the distance of a shore from a point in the sea. It is also used to see the horizon. If we know the distance from where we observe the building and the angle of elevation, we can find the height of the building. And if we have the value of one side and the angle of depression from the top of the building, we can find other side in the triangle. So with the angle of elevation and the angle of depression, we can find the other angles and also the sides of the triangle. So all of what we should know is the known fact should be a side, the length of one side, and the angle of the triangle. The next concept is set. The next basic concept of mathematics is set. So what is the set? It is a well-defined collection of objects. So it is not just a collection of objects, it is a well-defined collection of objects. Why we say well-defined? Because from the collection, we will be able to define what is it, what it is. Say, for example, if we have 2, 4, 6, etc., we can say that it is a set of even numbers. We can find, we have real application, life application, that we can find the set of plates, set of spoons, set of bowls in the kitchen. Another example is mobile showrooms. where we find smartphones separated from the ordinary ones. And there are infinite examples of sets in our day-to-day life. We often speak of collection of things as a single entity. The Detroit Lions, the House of Representatives, the Army, the Rotary Club, and the solar system. So here we have a set of books arranged in the bookshelf. Here we have set of jewels in jewelry box. And we can also find, we have also seen closet. What is a closet? A clothes arranged in a manner where the dresses, trousers, pants, coats are kept together as a set. So every type of dress is kept as a set, which we call it as a closet. The related clothing groups are separated and they're kept apart from other sets of clothing. And then from sets, we have the concept functions. What is a function? It is a relation between two or more sets. So see, we have the set of audience and I am the resource person. So I am related to the set of audience. So function is basically a relation between two or more sets. So if A and B are two sets, if every element of A has an image in B, every element of A is mapped to a unique element in B, then that is Y equals f of x. Let's say that set A, the element is denoted by small x, and it has an image small y in set B. So we write it as Y equals f of x. And so every element of set A has a unique image. It should not, no element of A should have one or two or more images. If it has, it is not a function. So the first figure is an example of a function. The second one is not an example of a function. So in function in mathematics, an expression, a rule or law that defines a relationship between one variable, that is independent variable, and other dependent variable. So y equals f of x. X is an independent variable. Y is the dependent variable. Say, for example, y equals x squared. Y depends on x. Functions are ubiquitous in mathematics and they are essential for formulating physical relationships in the sciences. So there are here we have few examples of functions. We can find how far someone travels after a certain amount of time. We can predict the expected tree growth and how much money to expect from investments and how much profit can be earned from sale. So these are some examples of functions. And here we have linear function and exponential function. Linear function, exponential function, and we have polynomial functions. This is an example of polynomial functions. And functions and derivatives are relate different concepts in economics. Economics, they use calculus, functional relationships, relation of income, market predictions, etc. So this is a example of polynomial function. So the next concept is limits. So we should know what happens when something is very, very large and what happens when something is very, very small. So for that, we have the concept of limits. So a limit is the value that a function or a sequence approaches as an input approaches some values. Limits are essential to calculate for mathematical analysis. They are used to define continuity, derivatives, and integrals. So limit of a function is defined as x tends to c, limit of f of x is L. As x tends to c, limit of the function is L. So we don't bother about what happens at x equals c. We bother only about what happens when x is around c. So here we have, see, when x is within the interval, that is a minus delta and a plus delta, and f of x lies in the interval n minus epsilon and L plus epsilon. So what we see, what happens when x approaches from left, that is left limit, what happens when x approaches from right, that is right limit, and if the function approaches the same value from both the direction, then we evaluate the limit. So here we have an example, limit of x plus 2 as x tends to 4. So when x left limit is 5.99, right? 0. So at some point, the left limit and right limit will be same. So there we have, but there we say as limit x tends to 2, limit x tends to 4, x plus 2 is 6. Then we have the real life application of limits. we have a chemical reaction in a beaker. We start with two chemicals which form a new compound over time. So we have a combination of two chemicals which leads to a new compound. The amount of new compound is the limit. The amount of new compound is a limit of a function as time approaches infinity. The amount of new compound is a limit of a function as t approaches infinity. So this is the practical application of a limit. Then we have the concept continuous function. A continuous function, we know that the graphs are smooth. There are no breaks or jumps in the graph. So we will be able to draw the graph without lifting the pencil. So here we have an example. We drop an ice cube in a glass of warm water and we measure the temperature with time. The temperature approaches the room temperature where the glass is stored. So measuring the temperature is a limit as t approaches infinity. Continuity equation can be defined in everyday life. The continuity equation defines a number of people alive. The source is accounted. The number of death is the sink is accounted. The sink is accounted for number of deaths and the source is accounted for the number of births. So these are some examples of continuous function. We have the graph is smooth. There are no breaks in the graph. From this, we have the concept calculus. So as we have arithmetic, study of numbers, geometry, study of shapes, algebra, the study of operations among variables, we say calculus is a study of change. Wherever change is there, we have calculus. So in this, we have the basic concept derivative. The derivative of a function of a real variable measures the sensitivity to the change of the function with respect to a change in the argument. The change of the function, that is output value, with respect to the change in the input. So the derivatives are fundamental tools of calculus. For example, the derivative of the position of moving object with respect to time is the object's velocity. Now, it measures how quickly the object changes its position with respect to time. And we have the application of derivative in chemistry. When two reactants react, it is important to study the rate at which the reaction is taking place. In such cases, derivatives are used in finding the rate of change in concentration of reactants or products per unit time. We have the application of derivatives in medicine. It is used to find the rate of growth of tumors. Doctors use the derivatives with respect to time to find progression or degeneration of a tumor. So we have V as a volume of tumor. The equation is V of t equals V naught e power at, where a is a constant. V naught is the initial volume of the tumor. T is the time. So V dash of t dV by dt is a standard growth rate. That is a rate of change of tumor volume. And next, we have the real-life application of calculus. And here we have an example of real-life application of calculus. Let us consider this problem. Job opportunities of people. Males and females are over 18 and under 16. We have government salary earners, company salary earners, and they are shown in a table. So we have the years, civil salary earner, company salary earner. They are in two groups, male and female. We can find the slope. With the slope, we can find whether the salary increases or decreases. The negative slope suggests that the salary is decreasing with respect to years. The positive slope suggests that the salary increases with respect to years. That's what we find in the example. Next, we have integration. So integration, the definite integral means area. It is the anti-differentiation, a technique of finding the function g of x, the derivative of which is known. So the infinite summation is equivalent to the integral. So here we have the applications of differential and integral calculus. So as I told you, differential calculus is used to find marginal cost, marginal revenue, maximum, minimum. Integration has application in finding area volume. So we can find the amount of water used to fill a swimming pool with the help of integration. So if we know the shape of the swimming pool, we can easily find the amount of water required to fill. Otherwise, we have to begin with a gradient. Companies use differential calculus to calculate the minimal payable amount. So there are several variables involved. The rate of interest have to be calculated. The interest rate account balances calculation have to be done simultaneously to provide the customer the minimum balance and the amount paid. Next, we have differential equation. So it contains a dependent variable, independent variable, and derivative of dependent with respect to independent variable. So here we have an example. The population of the community increases at a rate proportional to the number of people. So like N of t, the population, N of 0 is the initial population. So we have the differential equation here. If the population doubles in 6 years, so the population A is the population doubles in 6 years. So at t equals 6, it is 2A. So from that we can find A, and what happens when how long, what is the time required for the population to be tripled. That also we are able to find. So what happens when the population doubles in 6 years, and how long it will take for the population to become thrice. So that can be found by solving the differential equation. Another example is when a chicken is removed from oven, the temperature is measured at 300 degree F. 3 minutes later, the temperature is 200 degree. How long it will take for the chicken to cool off? So this is an equation. So t of 0 initial, it is 300. From that we get a constant C2 230 at so how long it will take for it to cool off at 70 degrees. So for that, we have 200 equals 70 plus 230 e power 3 alpha. So we solve for alpha. So we have found the time for that. Next, we have the concept probability. Wherever we have uncertainty, we have the concept probability. So it is a measure of likelihood or unlikelihood of the event. So when tossing a coin, throwing a die is simple examples of probability. So there are say if you take, if the sun will rise, surely it will happen. So there is 100% certainty here. When we toss a coin, both head and tail have equal chances. So the even chance, when we roll a die, there is no chance of getting a number 14. So it is impossible event. So probability is defined as number of favorable outcomes by total number of outcomes. And there's the practical application of probability is traffic signals. So we can estimate waiting time with the help of probability. It is used to control and observe the flow of traffic in highways. Accordingly, we can adjust the green light and the red light. Next example of probability is insurance. With use of probability, we can find the best plan of insurance which suits our family. So let's say that a person in a family is an active smoker. So the health insurance, we have to give priority to the health insurance compared to the other insurance. Since many are using mobile phones, we have to get the mobile phones insured because the chances of mobile phones getting damaged or lost are very high. Then we have the concept statistics. Statistics is a study of data, raw data. We have a collection, organization, presentation, analysis, and interpretation of data. So statistics have applications in controlling the epidemic, like cholera, plague, COVID, etc. And we have the record of number of infected cases. With the record, we can we can control the spread of virus. We can take preventive measures to control the spread of virus. Next application of statistics is production analysis. So we can implement the statistics to find the optimal production of goods. Next, we have matrices and graphs. So matrices, what is a matrix? It is a rectangular array. It is of elements in rows and columns. So the simplest example is that graph. Matrices relates to rows and columns. Graphs also relate to vertices and edges. So it is easy to study matrix through graphs and graphs through matrices. So acquaintance graph, say X is related to Y is related to Z. So like that, we can find the popularity of a person. So we can find the popularity of a person with the help of adjacency matrix. So this is the adjacency matrix, and we have the adjacency list. So this we have 1 is adjacent to 2 and 4, 2 is adjacent to 5, and 3 is adjacent to so on. So we have the adjacency matrix here, and we have the adjacency list here, and we can view matrix as graph. Every matrix corresponds to a graph. So the rows, 3 rows and 2 columns. So 3 rows in one side and 2 columns in other side. So we have a bipartite graph. So every matrix corresponds to a bipartite graph. Every matrix can be viewed as a function. The entries of the matrix correspond to the real entries or complex numbers. The entries of the matrix correspond to real or complex. And matrix multiplication can also be viewed as a graph. Unsymmetric matrix, we know that when a matrix is said to be symmetric, when transpose of a matrix equals itself. A symmetric matrix corresponds to symmetric graphs. So we have 3 rows and 3 columns. So there are 5 ones. So 5 ones correspond to 5 edges. So the product matrices M transpose M are symmetric. And so matrices with non-zero entries correspond to complete bipartite graph. If it has 0 entries, it is not a complete bipartite graph. So with this, I complete the talk. Any questions? Hello.
Yes, ma'am.
I'm
Participants.
really sorry for the disturbance.
No, ma'am. It
Sorry for the
happens.
trouble.
Ma'am, you don't have to be. It happens sometimes. So participants, if there is any query, you can write that in the chat box, or you can unmute yourself and you can ask Meenakshi ma'am. I think, ma'am, the lecture was so clear. Oh, yeah. Yes, ma'am, you can ask.
Ma'am, in econometrics we use trace test and maximum eigenvalues and
Yes.
the matrices. So can you please elaborate on that, ma'am? The mathematical part of it, which is used
Eigenvalues. Eigenvalues, you should have a square matrix. A square matrix is a matrix where number of rows and number of columns are same.
Okay.
So every square matrix, you can identify the square matrix with non-zero scalar, which we call it as non-zero vector, which we call it as eigenvector, and we have the corresponding scalar, which we call it as eigenvalue. So if you take a square matrix, you post multiply by a column vector in such a way that the matrix product AX equals lambda X. So that lambda is called as the eigenvalue, and the X is the non-zero vector, which is called as the eigenvector. Actually, this concept you can find in phone. See, when we try to adjust the picture in the phone, we enlarge the size or we reduce the size. The concept behind this is eigenvalue and eigenvector.
Okay.
And it is also used to find the pi electron energy of chemical compound.
Okay. Thank you, ma'am.
If you need elaborate thing, I have to share notes for that. Sorry, I don't have that in PPT here. Any other question?
Ma'am, if there will be any other query, then we can mail that to you.
Yeah, sure. Sorry, I'm not able to cover much because time was short. I didn't expect a disturbance.
Yeah,
I'm facing this for the first time.
no, ma'am, it
So
happens.
far, we have been giving lectures in Teams and Google Meet. I'm new to Zoom. I also didn't expect this much disturbance. I'm really sorry for it.
No, ma'am, you don't have to say sorry again and again. It happens sometimes. So, like we always say that maths is omnipresent. You just need to see it and visualize it. So that was really elaborated by Meenakshi ma'am in her lecture. She has covered a lot of aspects and by which we can visualize mathematics in our day-to-day life, and we can visualize in various things around us. So thank you, Meenakshi ma'am, for accepting our invitation and for giving such a thought-provoking address. I hope we will join again for another informative session. And now I invite my dear colleague, Miss Mehak, for the formal vote of thanks.
I deem it a great honor to propose the vote of thanks on this online national webinar on real life applications of mathematics. I sincere thanks to our research community for accepting our invitation and gracing this I also express profound gratitude to the organizers. First of all, the head of our institute, our our worthy, dynamic, and beloved principal, ma'am, Dr. Kiran Angra, whose exemplary vision is the foundation of this webinar. Ms. Anchal, the convener, who has left no stone unturned organizing today's webinar. We are also thankful to all the participants who have turned up in a such great number of ones. Again, I thank all of you for your cordial cooperation. Thank you.
Thanks for giving me the opportunity.
No, ma'am, pleasure was all ours. And hopefully we will have another session with you.
Yeah.
Yeah. So participants, the feedback link is being shared in the chat box. Just fill that for your certificates. I'm going to share it there.
There is one question, the chat bot. Mathematics, can we explain mathematics with the help of human body functioning? We can, there is one paper, people have worked on differential equations and graph theory to study COVID. So you can refer those papers. People have used differential equations and graph theory for studying COVID situation. Shall I quit, madam?
Yes, ma'am, you are allowed to click now.